Alternating series test. So we're going to talk about alternating series and convergence. But we'll also talk about something called absolute and conditional convergence, because those kind of pair up very nicely. All right, so absolute convergence is a series converges absolutely if now where do we use the word absolute?
In units bounded, so like the maximums.
You're going way too far with that.
No,
Absolute max or min?
right. When it,
Calculus.
sorry, not bounded. That was the wrong word. When it has a range. I forgot what it's called.
Okay, that's an option. Do we use that? Have we used max and min with these at all?
No.
No, we haven't. Okay. What more basic math concept has absolute in it?
Absolute value.
Yep. There you go. That's it. It's an absolute value of the series. Okay. So no negatives. All right. So what about this?
Is that and a natural log scale?
And
So -1 to the n over n squared.
right.
So we absolute value.
Okay, so this is an alternating series, right?
Uh-huh.
You remember what alternating series is?
Series.
The signs go positive, negative, right? Does that series absolutely converge absolutely?
Yes.
Does the series converge absolutely?
If you reduce it 1 over n squared.
So right?
Yeah.
Absolute value of that, which is the same as all ones are positive. Does that series converge absolutely?
Yes.
Do that.
That is a what test?
Series.
Yeah. Converges by P series. P-series 1. So, therefore, this series converges absolutely. Good with that?
Yeah.
This absolute convergence. Okay, here's what's nice about absolute convergence. If the series converges absolutely, Okay. Then, the series in general converges. So this is a way to show absolute convergence for an alternating series. It's not an alternating series test. It's not as broad as the alternating series test, but it does help in specific cases. Cool. Let's look at this.
Realize it apart. Keep this call. I don't see. Still skull.
Okay, here's another one. This is a series from n equals 1 to infinity of negative 1 to the n plus 1 over the square root of n. Converge absolutely.
No.
Oh. Why not?
It's easier to test.
Yeah. Got it.
Does that mean it evaporated, or is it just inconclusive?
No,
Test?
it doesn't.
So there's another step to this?
Use a different test.
Okay. You can say that, therefore, this series does not converge absolutely. Okay. So be careful not to assume that every alternating series converges absolutely. Some of them converge conditionally, is what it's called. Okay. And we're going to get the alternating series test, and then I'll show you how that shows conditional convergence. So, just run through your steps. But no, we cannot say that series diverges yet. So, all right. You'll get that. I hope. Here is conditional convergence. So, So conditional convergence happens when absolute value diverges, but the regular one converges. And I'll show you an example of that here. Is the alternating series test. So, we have to make sure that A sub n is a positive sequence. That is decreasing, and converges to 0. Now that's the sequence. Okay, so remember that sequence series difference. Okay, this is term by term. So what you're looking at basically is like A1 would be the largest, A2 second largest, A3, etc. Right. And they all have to be bigger than 0. So that has to hold. Then that series, so if you show that the sequence meets these conditions, the series
Converges conditionally?
converges. No.
Oh.
Just flat out converges. So you have 2 items on that page, conditional convergence and alternating series test, right? Okay. So, going back here, does that series converge conditionally?
Yeah.
So we've already shown this does not converge absolutely, right? So if we're going to show conditional convergence, we've already shown this, right? We just need to show that the series converges. How are you going to do that?
Limit test, not limit, as you know the others.
Alternating series test. Right. Okay. So, are all the terms of this series positive?
No.
Sorry, the sequence.
Yeah.
So we're looking at 1 over the root of n, because we don't consider the alternating part
Yeah.
with the sequence.
Yes.
Positive, all terms. How about decreasing?
Yes. Yep.
1 over 1, 1 over root 2, 1 over root 3. Okay, good. And greater than 0?
Mm-hmm.
Check. Okay, so we have met all the conditions of the alternating series test. So the alternating series test tells us that that series converges. Look at the sequence, meets the conditions. If it's alternating series, converges. Okay, so does this converge absolutely or conditionally?
Conditionally.
Conditionally. Okay, so we have converges, does not converge absolutely. That is conditional convergence. So converges.
Was that how you prove the
And-
fact of it?
Whoops.
Close enough.
Scribbles.
Scribbles are fun.
No, the numbers are parentheses. The brackets are drum symbols.
Brackets are drum staples.
Okay, so since the series converges, but the absolute value diverges, we have conditional convergence. Okay. And we showed that using the alternating series test.
Oh.
Good with that? Okay. That's all the new stuff for the day. That's alternating series test. I want to review with you though, error bound.
Okay.
Do you remember alternating series error bound?
That's where you use the two polynomial and take the next turn up, right?
Okay. Alternating series are easier than that. Do you remember how much easier?
Just go to the next turn.
Yeah, that's it. So let's consider a series. Show that is true. Remember that notation?
So show that the error bound is less than 1/7.
So the error bound for the sum of first 6 terms is less than 1 over the 7th term. That's what we have to do. Right? Because you have 6 terms, the sum is always going to be less than the next term. Okay? Right, so what is this? What is the 7th term? It's always absolute value. Nicely. Right. So the 7th term is
-1 to the 7th.
okay. Now remember, it's absolute value.
Right, absolute value.
So there you go. Which is a 7. You can write it a variety of ways. That's 1. Okay. That's true. Okay, here's another way we can work these. Show that, or show that. Find an n such that S sub n approximates the error bound S with an error less than n to the negative 30. Remember how to do these? Here's your key.
Okay.
Alternating series error. What is it?
Is the term minus the last one.
Right, so that if you have a sub n, what's my last term? Is 1 over capital N, right? Okay, so what do we use for the error bound?
1 over n plus 1.
Right. And that has to be less than or equal to 10 to the negative third. Okay. These are an exercise in keeping it simple, silly. Look at your keywords, just like if you see the word maximum, derivative equals 0, sign analysis. If you see the word error, you have an alternating series, next term, okay, and then it has to be less than. It says less than, this builds your equation for you. Alright, so now we just solve. N plus 1.
What's less than 1 and equal to? No, equal to 100. One over 100 is 0.001? Yep. Yeah, it's 100. 999. You're right, so it's
Oh, you did.
I didn't switch my signs. I'm done.
Morning.
Okay, and there you go. So we have to have more than or equal to the 999th term to have an error bound of less than 1/1000.
For the test tomorrow.
Quiz, Mason. Quiz. This is a quiz.
I
Wanna
don't
go to
know,
math
quizzes can
extravaganza,
also be
Monkey?
pretty detrimental
We'll
to
go to
your
math
career.
extravaganza.
Questions
Probably not.
about this refresher on error bound? Okay. There it is. About BC.
Four times.
We'll learn a lesson and not do any practice.
I thought it was gonna be a review for the kids.
You expect so little of me.
I'm sure just do the lessons that you were doing. Plus, we did it.
I'll tell you what. How many of you are going to the games tonight?
Hunter.
I have rehearsal.
I'll probably go. We still gotta go to the first part of the game.
Yeah,
So we
well,
can play the anthem.
yeah, but then we get to lose.
So we're gonna lose half the
District.
day.
Dufresne will be there. Hunter,
Yeah.
Will you?
Isaac.
Alright.
Maybe.
I'll be here anyway.
Daisy.
Yeah, so,
Bummer. Guess we have a quiz tomorrow.
okay.
Okay.
Wait, what did I have to do the other thing?
Since we have districts. We can either do the quiz tomorrow or have the homework due tomorrow.
Quiz.
Quiz tomorrow.
Quiz.
Okay. Homework's due Thursday. You're welcome.
Why?
And you can thank your basketball teams for hosting.
Who's?
I don't even think about it.